So the cool thing, if we can visualize multiplication as the area of a rectangle, then that can help us actually multiply any two numbers or expressions pretty efficiently. So for example, if I had a x plus 2 times an x plus 7, right? Now, for some students, they might remember the distributive property, but if you haven't learned the distributive property, if we can just think about this product as a length times width, we can understand that this solution is now going to be the sides of a rectangle. So all I simply need to do to find this product is to create a nice box, understand that x plus 2 can represent this one of the sides, and the x plus 7 can represent the other side. Now, the confusing part in this case is we don't know what the x is, right? When we have numbers to represent there, it gives us a quantitative idea of how large or big those sides of the rectangle can be. But in this case, x is arbitrary. So what I'm going to do is just break up my rectangle into evenly spaced out rectangles. Now remember, when I want to find the area of a box, I'm simply just going to multiply my length times my width. So x times x is going to give me a x squared. X times 7 is going to give me a 7x. X times 2 is going to give me a 2x, and a 2 times 7 is going to give me a 14. Now you can see that the area of each of these rectangles all add up to give me the area of my larger rectangle, which is going to be the product, which is the answer I am looking for. Now when we're dealing with combining these, we can only add variables that have the same power. Since there's no other expression with an x squared or with a number, I'm going to leave them as they are. But in these two rectangles, you can see I have a 2x and a 7x raised to the first power. So therefore, I can combine them to give me a 9x. And that is going to be my final answer. Now, understanding this visualization is very helpful in understanding as well as remembering the distributive property, which I'm going to cover in the next video.